This is part 1 of the logarithms videos. We are going to talk about what logarithms are, convert between log and exponent form, evaluate log expressions, and solve some equations with logs. The first thing we need to think about is what we know about exponents in general. So if I gave you the expression 3 to the power of 4, we know that that's 3 times 3 times 3 times 3, which equals 81. And so with this information, we can answer the question, 3 to the power of what equals 81? We know that that answer is 4. But if we didn't know that, we would need some way to answer the question, 3 to the power of what equals 81? And log notation gives us the ability to do that. So log base 3 of 81 equals x means the same exact thing as 3 to the power of x equals 81. So now that we know how to interpret the log notation, we can practice a little bit. If we look at the expression log base 2 of 8, we know that this notation is asking the expression 2 to the power of what gives me 8. And we know 2 times 2 is 4, times 2 is 8. So this is 2 cubed. So 2 to the power of 3 equals 8, which means log base 2 of 8 equals 3. Another example is log base 3 of 27. And this is asking the question, 3 to the power of what equals 27? We know 3 squared is 9, and then 9 times 3 one more time is 27, so 3 cubed equals 27. This answer is also 3. A lot of times when you're doing these examples, it helps to set your expression equal to some variable so that you're working with an equation instead of just an expression. So if I'm looking at log base 5 of 25, I might say that equals x, so that I can rewrite my equation instead of just working with an expression. So this is asking the question 5 to the power of what gives me 25? And we know that x equals 2 makes that true. So log base 5 of 25 equals 2. The next thing we're going to look at is how to solve log equations. So here is an example of an equation that has a log expression in it. Log base 3 of 243 equals 2x plus 1, and I want to solve for x. So the first thing I'm going to do is try to figure out what log base 3 of 243 is. So let's write that out separately here. Log base 3 of 243 equals, let's use the letter m, just as a stand-in for right now. So this is asking the question 3 to the power of what gives me 243. And I've got 3 to the first equals 3, 3 squared equals 9, 3 cubed equals 27, and 3 to the fourth equals 81, 3 to the fifth equals 81 times 3 is 243. So we know that log base 3 of 243 equals 5. So I'm just going to make some space here on my page, and I can substitute the value 5 in for log base 3 of 243 now. So 5 equals 2x plus 1, and then we're just solving a regular equation. 4 equals 2x, so x equals 2. Let's look at one more example. We have log base x of 16 plus 7 equals 9. So I want to solve for x here, and I'm just going to start by trying to isolate that log base x term. So I'll subtract 7 from both sides. Log base x of 16 equals 2. And so this is asking the question, x to the power of 2 equals 16. What is x? I can take the square root of both sides, and I see that x can be positive or negative 4. So that's another type of equation that would involve logs that you might encounter. We've seen an x outside of the log expression, we've seen an x in the base of the log expression, and my last example is going to have the variable in the log but not in the base. 5 minus 3 log base 4 of 2x equals negative 4. So as always, I'm going to try to isolate the term that has the x in it. So I'll subtract 5 from both sides. And I've got negative 3 log base 4 of 2x equals negative 9. Divide by negative 3 on both sides. So log base 4 of 2x equals positive 3. And now my equation is asking the question, 4 to the power of 3 equals 2x. What is the value of x? And 4 cubed is 64, because 4 times 4 is 16, times 4 again is 64. So I've got, I'll go up here, 2x equals 64. And then I just need to divide by 2 on both sides to solve for the value of x. So x equals 32. So this was part 1 of a 3-part series on logs. Make sure you catch the other 2 parts and then do the practice problem set before scheduling a retake.